Um, quick review. We met some of my family. We established kind of a rule of thumb about family trees, about how once you hit a fork in the family tree, the two family lines keep getting more and more genetically different. It's called descent with modification, right? Your descendants change, they get modified more and more and more and more. They get differenter and differenter from the parallel branches of the tree because of this phenomenon. It works for humans, it works for bears, right? It's all about how long ago their common ancestor was. And because it's so consistent, you can use it to like track evolutionary time. You can go, all right, they're this different. That means, it was only 7 million years ago they had their common ancestor, whereas these guys are that different from here. So it's more like 22 million years ago. It's sometimes called an evolutionary clock, a molecular clock. Very useful thing, Darwin's first big idea. At this point, you don't have to write this part because you've written it before in our introductory unit. But as we continue to talk about evolutionary theory, which has been modified and changed after Darwin, it's worth remembering that a theory is kind of the best explanation we've got about something in the natural world. Other theories include Newton's theories of gravitation, Einstein's theories of relativity, and special relativity. So we're not just talking about some, weird idea where there's a bunch of other ideas here. We're talking about kind of how we explain this based on everything that we've learned. Okay, time for the second big idea. The one you already... No, not Pangea.
You said we're not doing it.
I mean, we'll mention it. But that wasn't Darwin. Darwin used that. But that was two geologists named Hutton and Lyell that figured out that the continents are moving.
They were on. Guided reading.
They were geologists, yep. And that's the whole thing where they started to find fossils in weird places that matched up. They realized that the globe is like a big puzzle, right? That stuff fits together. Cool stuff. And that's what got Darwin thinking in terms of geological time. And that led to the descent with modification stuff. But his second big idea, I think, is kind of almost a no-brainer at this point for you. Natural selection. You know that one? Yeah. What's the slangy definition? Survival of the fittest. Yeah, it's not a bad description. People use evolution and natural selection interchangeably sometimes. That's a mistake. Evolution is the change itself, right? The change that just happens. Natural selection is one of the mechanisms, not the only one. There are other ways that populations evolve. Natural selection is just one, but it's maybe one of the more important ones. Darwin figured it out partly by looking at domesticated animals. What we just talked about last chapter about selective breeding and how powerful it is, right? That you can get a poodle from a wolf. I think he was actually looking at cows, which is a little less interesting to me. But to him, it kind of flipped the switch. He called what we call selective breeding, he called it artificial selection. And he basically said, well, shoot, if we can do that, if we can, turn whatever a cow used to be into a cow, we can turn a wolf into a chihuahua. Just by picking the ones we like. Doesn't it make sense that a population that functions the same way genetically in the wild, doesn't it make sense that the environment is doing exactly that all the time? The environment is picking the ones it likes and letting them survive and breed. and not allowing the ones it doesn't like. Not that the environment likes anything, but it presents challenges all the time, right? It is naturally selecting as opposed to us artificially selecting. Does that make sense? Okay, let's just write down the basic rules and then we'll watch a movie about dogs. Here's how it works. And I know you understand natural selection, but here's where we have to kind of lay out the basic requirements and steps. And this is a little more complicated. So what you need in a population for natural selection to work is it doesn't happen to all populations all the time. First of all, you need genetic variation. Now that's there in all populations. There have to be genetic differences. There have to be things to choose from. Even bacteria have this, right? Because of mutations. Second, the thing he learned from actually an economist named Thomas Malthus, who actually studied poverty in England, was that basically all populations tend to have more babies than can be supported in the environment. And that leads to what? The third condition. What's variation and overproduction going to lead to in a population? What are those offspring, which there's too many of to survive, going to have to do? Somebody said it. Competition. Yeah. Struggle. Those are the requirements. Most wild populations on Earth fulfill those requirements. And those three conditions lead to the following thing happening. Number one, the critters with the helpful variations, with genetic differences that help them, are going to survive better. And surviving better means they're going to have more babies. That's the important part. The fact that some of them are surviving better, having more babies because of genetic traits, means that now if we focus on those genetic traits, some of them, the helpful ones, are going to be becoming more common, more frequent in the population. And the ones that are less helpful are going to be kind of going away in the population, becoming less frequent. And that fits our definition of evolution. That is genetic change in a population. Questions? That's basically it for Darwin. The two big ideas he had. Of course, he did tons more work. Some of it's super interesting, some of it's not. Origin of Species, the book he wrote, it's a tough read. We're not going to spend too much more time on it. But the two big ideas, descent with modification, natural selection. Any questions?